When using hybrid insulation systems, we are generally concerned with three key design elements: the project climate zone, the R value, and the interior humidity and temperature conditions.
Hi, I'm Robert Knighty, your spray foam advisor and the guy in the Hawaiian shirt. I wear the Hawaiian shirt as a symbol of freedom and flexibility, something that all business owners should want to achieve. You know how most SPF contractors start their business because of their technical skills, but they have no plan for growth? There's no consistency because decisions in their business are made on the fly. They are just trying to get through the day. And they are spread too thin because they do everything themselves. Well, what I do is help SPF contractors like that measure profitability, identify the key activities that drive success in their business, and create a game plan that develops consistency and growth. Let's get into it.
Here is some guidance on the proper design and installation of hybrid systems in southern climates. These concepts are based on guidelines developed by SPFA, published in the SPFA 146 guidance document, using a series of hygrothermal analysis completed by a consultant, assuming several different failure criteria. We are going to focus on the design of hybrid insulation systems within the building enclosure with the intent to target code-required R values and minimize the potential for condensation and air leakage. As previously discussed, a hybrid insulation system uses a partial fill of spray foam to reduce air leakage and provide a portion of the total R value, and then adds fibrous insulation to provide additional R value. Generally, the SPF is installed in the cavity first, against the exterior sheathing, and the balance of the cavity is filled with another type of insulation, which could be fiberglass batt, blown-in fiberglass, rock wool, wet spray cellulose, dense pack cellulose, another type of spray foam, or reflective insulation. When using hybrid insulation systems, we are generally concerned with three key design elements: the project climate zone, the R value, and the interior humidity and temperature conditions. The project climate zone is important because different climate zones require different approaches to designing these hybrid insulation systems. And according to the International Building Code, in climate zones 1 through 3, interior vapor retarders are typically not required for moisture management. The R value has two critical components, specifically the total code-required R value for the cavity and the minimum spray foam R value for condensation control based on climate zone and the total cavity R value needed. And finally, the interior humidity and temperature conditions determine the failure points. The biggest risk with hybrid systems is the potential for condensation. We must start our assumptions somewhere, so we typically begin with typical operating conditions for residential homes. Unusual occupancies with higher relative humidity, larger temperature differentials, or special designs like pool areas or cold rooms will require additional analysis. The key question in the design of the hybrid application is what is the minimum recommended thickness of spray foam to minimize the risk of condensation. There are several factors that determine the minimum recommended design thickness for hybrid applications. In climate zones 1 through 3, the design thickness can be determined by identifying the greater of 1/2 inch minimum closed cell spray foam, 2 inch minimum open cell spray foam, the minimum thickness to qualify as an air-impermeable insulation, the minimum manufacturer recommended application thickness, or 17% of the total installed R value. Let's look at an example of a hybrid application in Climate Zone 2, like Houston, Texas, with an R13 wall requirement. Upon discussion with your SPF supplier, you discover that both their closed cell foam and open cell foam have been tested as air-impermeable insulations at 1 inch thick. Furthermore, their closed cell foam has a minimum recommended thickness per pass of 1 inch, and their open cell foam has a minimum recommended thickness per pass of 3 inches. And finally, 17% of the installed R13 is R2.2, which would be less than 1/2 an inch of the closed cell foam and less than 1 inch of their open cell foam. So it looks like this in a table. By reviewing this table, you can quickly see the greatest thickness for each product, in this case, 1 inch of closed cell foam, or 3 inches of open cell foam. In this part of the country, most walls are made of 2x4 wood studs, which gives us a cavity space of approximately 3.5 inches. So trying a hybrid application with 3 inches of open cell foam doesn't make much sense. You might as well just fill the cavity with open cell foam while you're there. On the other hand, you can apply 1 inch of this closed cell foam in the cavity and fill the remainder of the cavity with another type of insulation and have little risk of condensation in this climate zone. While this is a standard way to approach a hybrid insulation application, as with any application, make sure that the path you are taking meets local building code requirements. Additionally, remember that the minimum recommended design thickness is going to be dependent on the specific spray foam products you are working with. So consult your supplier or review their technical documents to answer the questions previously discussed to make sure you are using the appropriate thickness of your products.
You've just watched an excerpt from one of my live trainings. Like this video and make sure to subscribe here on YouTube so you are notified when we release future videos. And if a strategy discussion might be helpful for you and your business, you can book a call with me at spfbiz.com.